This is the course module for the Ubuntu services and run levels. First, we'd be starting by talking about the run levels, how they differ for different distributions of Linux, how to stop and start a service on a run level, how can we change the run level, whether we need to shut down a computer in order to change the run level, how can we compare the run levels to the safe mode as of the Microsoft Windows, and other things about it. And after that, we'd be talking about certain services. The term run level refers to a mode of operation in the computer operating system that implement Unix system V-style initialization. It can be compared to the safe mode that we have in the Microsoft Windows. For the Unix-based operating system, we do not need to shut down the computer in order to change the run level. It can be done while the computer is running. Talking about different run levels. Each run level consists of a set of scripts that are executed when that run level is selected. Run level numbers 0, 1 and 6 are common in almost all distributions of Linux. However, 2 to 5 are the run levels that may vary. For example, according to Ubuntu and Fedora, they may change. And during the startup of a computer, only one run level is executed. Run level 1. This is an interactive run level for the Unix system in which only one user, which is generally the root user, is allowed access. Most daemons are not running in single user mode, and only some maintenance utilities like fsck work on it. This is usually used to perform administrative and maintenance tasks. The run level 0 and 6. Run level 0 or halt is used to shut down the system. The run level 6 shuts down the system, closing necessary applications and daemons, and then reboots it. Since run levels 2 to 5 differ according to the Linux distribution, the following table shows what the run levels 2 to 5 exactly are for Red Hat and Fedora Linux. For example, run level 2 for Red Hat and Fedora is multi-user mode console login without networking, and so on and so forth for the other Linux distributions. Therefore, for Linux, there are 7 run levels numbered from 0 to 6. Though we can have as many as we want, but these 7 are sufficient. Hence the run levels are 0 for system halt, 1 for single user, 2 for full multi-user mode, that is a default run level, 3 to 5 are same as the 2, and 6 for reboot. For a Linux distribution, all the run level directories 0 to 6 can be found in the /etc folder. Therefore, when I am in my root directory, that is I do cd/etc, I go to the etc folder. In the etc folder, I would be having other contents, but by doing ls, that is listing the contents, I would find the file. This has given us all the files that are present in the /etc folder. Here are the files for the corresponding run levels from rc0.d to rc6.d. Now these are certain useful terminal commands that would help us in dealing with the run levels. Who -r prints the current run level. Run level displays the last and current run level.lf. If there's no previous run level existing, then it displays n for none. Tell init sets or changes the run level to an argument specified. Now going to the terminal to execute these commands, first we type who -r, which tells us that the current run level is 2 and gives the time when it was started. Now we'd be opening the run level file that is present in the sbin folder. So the run level file, this command tells us that the previous state of the run level wasn't there, so an n for that, and a 2 for the state of the current run level. Now the tell init thing, we like to change our run level to 4. It tells us that it needs root permission to do that, so we'd add a sudo in the beginning, entering the sudo password for the user. The run level has now been changed to 4. In order to check that whether it has been changed or not, we'd be running again the sbin/run level command. So the previous state was 2 and the current state has been changed to 4. Now talking about services. Each run level directory contains a set of services which are executed when that run level is invoked. These services can be found in the /etc/init.d, and the configuration files corresponding to these services can be found in the /etc/init. The user can make changes in these configuration files to start or stop a particular service in a run level. Starting and stopping services. Inside the run level directories are links to daemons, shell scripts and programs that start and stop when the run level is invoked. The links prefixed with S start when that run level is invoked, and the links prefixed with K stop when that run level is invoked. Any daemon takes care of stopping and starting other daemons according to the current run level. Now going to the terminal and changing our directory to the /etc/ the directory for the run level 2. Now we read the readme file for this run level, and it tells us that the scripts in this directory are executed each time the system enters this run level. And also, to disable a service in this run level, rename its script to in this directory so that the new name begins with a K and the 2-digit number, and run the update-rc.d script defaults. Now this would do the changes that we need. In order to re-enable a service, we can just do the reverse by adding an S in the beginning. Certain files have an S in the beginning, that means these services would start. Now with the help of a YouTube video, we would learn how one can configure the GUI GNOME on Ubuntu.
If I wanted to set that up at boot so that I wouldn't run that graphical environment, unlike Fedora where I would just set it to default to run level 3, in Ubuntu I would want to go into etc and init, and I need to make use of my configuration file. So I have gdm-conf. This is actually what I want to edit here, and I'm going to do sudo nano and gdm.conf. Boy, I'm really late tonight. Lots of coffee and lots of Butterfingers. But I could modify any of these settings, but I'm just going to comment out these lines here, and I'll leave the stop there. Stop on Runlevels here 16-bit, and then I'm going to save this file. And so when I reboot, what's going to happen is it's not going to actually load GNOME. So it's going to bring me into sort of a text-only mode or console mode. Even still, my services, this right now is an FTP server. That server will still be running. It'll still serve out FTP pages, but sans the extra CPU cycles in memory to run my graphical desktop. So to test this out, I'm just going to reboot, sudo reboot. I really can't type tonight. Sudo reboot, okay. And let's bring this up into a text-only mode. Okay, now I'm in a text-only mode, and I'm just going to log in and okay. And so in this text-only mode, again, if you look, I still have my FTP server running. So let me try FTP localhost, and notice, welcome to the FTP service on Raptor 3. Anonymous access has been enabled for your downloading pleasure and convenience. And I'll just do an anonymous login. So everything is, as far as my server daemons and services, they're still running, but I don't have the added expense of, running, again, if I were going to look at my processes, there are no such GDM processes running, okay? And let's take a, look at GNOME. Alright, so that's a lot of memory, that's a lot of CPU cycles that I can apply towards serving out files via my FTP server, or Apache 2 web server, or my Samba, Windows file server, and optimize the performance better on this Ubuntu machine. And then, if for some reason I need to log on the machine and change some things, or configure some things, and I don't want to be in a text-only environment, no problem. I can just say sudo and gdm to launch the GNOME Desktop Manager. Let me authenticate with my password, and it'll go ahead and start launching X Windows. Well, if I type the password right. And it'll launch X Windows and bring up Ubuntu. now I can go in here and change the things that I want to